Hi, this is Gideon, Ayim Mensah. My student ID number is S1255024. This video is for the assessment of the potential vulnerabilities and impacts of climate change in Tarkwa, projected to 2030. Tarkwa is the capital of the Tarkwa Ayim district of Western region of Ghana. It is geographically located on long coordinate latitude 5 degrees 18 minutes and 23 seconds north, and longitude 1 degrees 59 minutes and 5 seconds west, and it is 86 meters above sea level. The 2013 population of Tarkwa is 34,941. The Tarkwa Community Center is a bold composition set in the prime location of the settlement, in front of playground and overlooking the rusting metal roofs of ramshackle houses. Most of the buildings in the city is mainly story, with a blend of distinct feel of Le Corbusier architecture. The buildings in the villages are the traditional mud and thatch housing, with a serene environment depicting a typical rural setting. The main occupation is mining. Tarkwa is said to be the first place mining activity started in the country. At the time of the Geological Survey Department was established in 1913, underground gold mines had been operating in Tarkwa. In fact, before the Europeans from Portugal and Britain arrived between 1453 and 1622, the indigenous people were extracting the minerals from deep pits, and women and children were panning for gold dust in rivers and streams, according to the Statistical Service of Ghana 2014. Tarkwa lies within the southwestern equatorial climate zone. The temperature are highest on average in March at around 27.4 degrees Celsius, and August is the coldest month with temperatures averaging 24.2 degrees Celsius. Sunshine duration for most of the year averages 7 hours per day. Relative humidity is generally high throughout the year, between 70 to 80%, and in the dry season 75 to 78% in wet season. Tarkwa is within the municipality that has the highest rainfall pattern in Ghana. It has a mean annual rainfall of 1,500 millimeters, with a double maximum rainfall starting from March to September as the main rainfall season. The least amount of rainfall in Tarkwa occurs in January, with an average of 37 millimeters. Most of the precipitation here falls in June, averaging 278 millimeters. It is believed that Tarkwa has a peculiar rainfall pattern, in that during the rainy season it rains at 2 p.m. That's the nickname of my hometown in Tarkwa, is Tarkwa at 2. Severe weather events at Tarkwa. It rains nearly every day in Tarkwa, just as it rains in Scotland in the UK. However, in Tarkwa's flooding events that occurred in 2013, it's dubbed as one of the severe rainfall pattern in Ghana. Dubbed as the lowest rain in the ancient Bible times, in May 2012, it rained a little over a fortnight. The rainfall reached 1,250 millimeters, whilst temperatures decreased by 45%, the most coldest weather experienced in Tarkwa. Houses, roads, and the only rail line that links Tarkwa to Accra, the capital city, submerged, whereas schools and hospitals took stock of their losses. Structures within the floodplains along the spurs collapsed, mouths and waste flew, washing away bridges and properties and lives. The cause of the severe rain has been linked to illegal mining activities in Tarkwa, obstructing the valley plains and natural courses of water bodies, with heaps of sand, uncovered pits, processing structures, refuse dump, and buildings, according to the study conducted by Kwesi et al. In 2015. Projected climate change in West Africa and Ghana. Now, before I explain the graph that you see, it is important to know that these predictions are based on scenarios. The recent and the one used in this presentation is the Representative Concentration Pathway, RCP. These are used to estimate how much impact greater or lesser amount of climate change would have on different possible states of the world. So RCP 8.5 means relatively high scenario, and this is consistent with the future with no policy changes to reduce emission. RCP 2.6 means low emission, and this is consistent with the fact that ambitious greenhouse gas emission reduction would be required. So from the graph of the West Africa region and the near surface air temperature, the West African region is expected to be hugely impacted by a rise in temperature ranging from 3 degrees Celsius to 6 degrees Celsius, according to the IPCC 5th Assessment Report. These unprecedented climates are projected to occur based on the scenario RCP 8.5, earliest from late 2030s to early 2040s. Under the RCP 8.5 scenario, according to Diffenberg and Georgi study in 2012, it predicted that the projected temperatures will exceed the 1986 to 2005 baseline by between 3 to 6 degrees Celsius. Comparing with global trends, the West African pattern are projected to occur 1 or 2 decades earlier than the global averages, according to Nain et al. In 2014. This is because the relatively small natural climate variability in this region generates narrow climate bounds that can easily be surpassed by relatively small climate changes. The precipitation, on the other hand, is not easy to predict like temperature, and this results in higher uncertainties for the entire climate projections, according to Rowell 2012. In general, the difference between the model bias of the scenarios RCP 8.5 in orange and RCP 2.5 in light blue is obvious for temperature but not for precipitation. But overall, there is a low confidence of delay in the onset of rain season in West Africa, with intensification of late season rains in the latest projects of the Couple Model Intercomparison Project (CMI P5). Now let's come to Ghana. Under RCP 6.5, the mean annual temperature is projected to rise by about 4.8 degrees Celsius on average from 1990 to 2030. If emissions decrease rapidly, the temperature rise is limited to about 1.2 degrees Celsius. This projection is consistent with the West African trend for temperature rise, but may have a severe consequence for Tarkwa, the steady area, because if the trend stays the same, it is likely to boost cocoa production in the area, which generally thrives very well under extreme temperatures. Considering rainfall under a high emission scenario for Ghana, the RCP 8.5, the number of days with very heavy precipitation, 20 millimeters or more, could increase by about 4 days on average from 1990 to 2030, increasing the risk of floods. A few models indicate increases as well, but outside the range of historical variability, implying even greater risk. If emissions decreases rapidly, the increase in risk is much reduced. Key sectors and their vulnerabilities. The heavy rainfall pattern predicted could affect sectors such as settlements, agriculture, health, water, and ecology. The last heavy rainfall in Tarkwa not only results in loss of homes, schools, and buildings, it also destroyed lives and properties. The situations will be worse in Tarkwa as illegal miners pits that continue to divert the water away from natural causes and man-made channels such as culverts and destroys properties. Then also, the agricultural sector will be seriously affected when there is a heavy rainfall. Apart from crops being swept away by the flood, increasing variability of rainfall increases the risk associated with farming as predictions becomes almost impossible. Falling rainfall affects the generation capacity of water treatment dams. Then also salt water intrusion along Tarkwa, a typical coastal community without centralized water system, will deprive the community of potable water. Then also, rising temperatures and frequent drought will increase the incidences of bushfires and environmental degradation. Another sector that will be severely affected by a flood is the health sector. Flood in Tarkwa will not only wash away properties but also carry in it solid waste as well as industrial waste from the mining, and these are likely to spread diseases such as cholera. Transboundary impact of climate change. The Tarkwa link is one of the first railway built in 1903 to transport gold and agricultural produce. It serves Ayawaso, another mining town, to Takoradi Port, to Kumasi, and to the capital Accra. In case of flood, the rail lines will be covered, making it difficult to transport cash crops such as cocoa and gold, the two main export goods of Ghana. Then also, the railway links the Ivory Coast border, where intertrade between Ivory Coast and Ghana are conducted. Flood will destroy such intertrade arrangements. Flood may also destroy power links with the power electricity network of Tarkwa. This is because all the power and electricity networks are above instead of being below ground level. And so when there is rain and then there is flood, this can destroy it. This can also result in excessive power shortage, and which will affect the legal operation of mines in Tarkwa. That's the end. Thank you very much.